Good morning children. Welcome to online class. In the last class we have studied about the steps in the construction of a graph. Now in this class we will see what is direct proportion and how to identify the given problem in the graph. Now we will see. For this one we have to do an activity. What are the materials required for this one? Now I will tell. For doing this activity we need a spring balance, and weights in grams and a stand. Children, this is an activity in order to identify the direct proportion. For this one we have to take a spring balance and a weight hanger and a stand. And for the first time this experiment was done by Robert Hooke. He is a famous scientist. The name of the scientist is Robert Hooke. He did this activity in order to know the relation between mass and elongation of the spring. Okay children. So that's why this law is known as Hooke's law. Hooke's law. He studied the relationship between the mass and elongation in the spring. Now how to do this activity? Now we will see. So this activity is named by the scientist Hooke. So this is known as Hooke's law. For the first time he framed. Now you see here there is a table. In the first column we have written mass and in the second column elongation. Here mass is taken as our wish. So this mass is known as dependent variable. In the last class also I have told you about what is a dependent variable, what is an independent variable. Dependent variable means this is of our choice. That means mass. In grams we can take from 50 grams, 10 grams, 20 grams, 30 grams, 40 grams, 50 grams. We can increase the grams. Okay children. So here it is our wish. So this mass is known as dependent variable. And whereas elongation in the spring, how much the spring is elongated, that we have to write from the activity. So for this one, elongation is the independent variable. So it is taken as y-axis. Is this clear children? Mass is taken as our wish in grams. We can take start from 10 grams, 20 grams, 30 grams. Like that we can increase. And elongation from the activity we have to write. So this is an independent variable. Now for this one, first this is a spring. This is a spring. And for this one we have to hang weights in grams. That is our wish. We can start from 10. So here we can take it as 10 grams. So how much the spring? First of all, initially the spring is like this. There is no elongation. Here we are adding grams, 10 grams to this spring balance. So after adding the weight, how much the spring elongated is we have to record. We have to measure with the help of a scale children. So up to here initially the spring is here, and after adding the weights the edge of the spring come to here. So that's why some elongation. Elongation means increase in the length of the spring. Definitely initially spring is like this. If you add some weights to that one, its weight as the weight increases, the elongation also increases. So after adding another weight to this one, the elongation in the spring increases. So here as we are adding weights, as we are increasing the weights, the elongation in the spring also increases. Children, once again, here we are keep on adding the weights. First 10 grams we have to add. After that you have to add another 10 grams. Like that we have to keep on adding the weights. Then what we have to observe, is there any change in the spring? Definitely by adding weights, the spring length of the spring also increases. That is measured with the help of a scale, and we have tabulated like this. First of all, any measures you have to start from 0. So if there is no mass attached to the spring, there is no elongation. So initially the readings are recorded as 0 and elongation in the spring also 0. Now if you add 10 grams to the spring balance, then how much the elongation? That is in 2 millimeters. Elongation is taken in millimeters here. So in the first case initially 0 0, and if you add 10 grams of weight to the spring balance, then elongation in the spring is 2 millimeters. And again if you add 20, then the elongation in the spring is 4 millimeters. We are keeping on adding like this. 30. If you have added 30 grams, then the elongation in the spring is 6 millimeters, and 40 grams and it is 8 millimeters, and 50 and then 10. Now here we have to represent this data in the form of a graph, children, and here this is a graph and it is x-axis, and the horizontal one is known as x-axis and vertical axis is known as y-axis, that we know. And here in this column mass is taken as along x-axis. Why? Because I told you this is a independent variable. That's why always independent variables should be taken on x-axis. Here the independent variable is mass. That means here we have taken weights according to our wish. Therefore here 10, 20, 30, 40, 50. So 10, 20, 30, 40, 50. And here elongation. Here it is elongation. It is taken on y-axis because it is independent value. Okay, children. So here elongation 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, 12. So after that we have to plot a graph between this mass and elongation. Mass and elongation. So see children, mass is taken as x-axis. That is the first point 0, 0. So 0, 0 point is here, and next 10, 2. And x-axis 10 and y-axis 2. So this is the second point. Next 20, 4. Next 30, 6. 40, 8. 50, 10. Like this we have to label the points on the graph and then join all the points. Then we will get a straight line, children. So this is a straight line. So what information do you get by changing by seeing this graph? Now we will see. Here the initial value should be counted as 0. Here it is always the first values are 0. Next, coming to the ratio of any two quantities is found to be constant, except leave the first one, 10 by 2. What is 10 by 2, children? 5. 20 by 4, 5. 30 by 6, 5. 40 by 8, 5. 50 by 10, 5. So here the ratio of any two pairs has to be constant. Constant means same. We will get the ratio of these two quantities along this table is found to be a same value. That same value is known as constant. So the ratio of any two pairs has to be constant. And last one, if the value of one quantity increases, the value of the second quantity also increases. So I will explain with the help of this table. If the one quantity is increasing, here the mass is increasing, 10, 20, 30, 40, 50. So here the mass values are going on increasing, and elongation. See children, if you go observe this one, 2, 4, 6, 8, 10. If you increase the mass, then the value of the elongation of the spring also going on increasing. 10, 20, 30, 40, 50. Here the mass values are increasing. 2, 4, 6, 8, 10. Here the elongation is also increasing. So from this table, if the value of one quantity increases, the value of the second quantity also increases. So that means here, if the direct proportion means if one quantity is going on increasing, the other quantity also increases. This is known as direct proportion. that in the direct proportion, if the one quantity is keeping on increasing, the other quantity also increases, and the ratio of any pair of has to be found to be constant. So children, this is about the relation between mass and elongation of the string. If the mass is going on increasing, then the length of the elongation also increases. So this relation is found to be direct proportion. Why? Because I told you now, if the one quantity increases, then the other quantity also increases. So children, and here in the activity given in the textbooks, you have some points, some questions. What is taken on the x-axis? What is taken on the x-axis? Mass. What is taken on the y-axis? Elongation. And what is the range of the x-axis? What is the range of the x-axis? Means here we have taken mass on the x-axis. So range means highest value minus lowest value. So what is highest value in this one? 50. Least value 10. 50 minus 10, 40. Next, range on the y-axis. What is the highest value from this table? 10. What is the least value? 2. 10 minus 2, that is 5. Don't consider this initial values, children. Next, 10 minus 2, 5. 10 minus 2, 8. So here the range values are okay. Next, scale. What is the scale on x-axis? On scale we have taken 1 unit is equal to 10. What 1 unit is equal to 10 grams. So 10 grams, 10, 10, 10. The initially here we have taken 1 unit as 10 grams. And what is taken a scale on y-axis? Here 2, 4, 6, 8 like that. So 1 unit is equal to 2 millimeters, children. That is scale on y-axis. Next, naming on the x-axis. What we have taken on x-axis? Mass. And what we have taken on y-axis? What is we have taken on y-axis? Elongation. Next, data points. Data points means 10, 2. 10 is on x-axis, 2 on y-axis. 20, 4. 30, 6. 40, 8. 50, 10. So these are the data points. Labeling data points. We have labeled the points on the graph and we have got a straight line. This straight line graph indicates that the quantities given in this problem are in direct proportion. Children, here we have got a straight line. This straight line graph indicates that the given two quantities are in direct proportion. Or if you have given a graph like this, then what can you say about the two quantities if they ask? Then you have to say that these are in direct proportion because one quantity is increasing and the second quantity is also increasing. So here we have got a straight line. This straight line graph indicates that the given problem is in the given quantities are in direct proportion. See children, I thought that you understood properly. In the next class I will tell you about indirect proportion. Thank you children.